Hello, excuse me, hello Math 120, and this is Professor Gonzalez. And I'd like to do the problems, the homework problems from section 1.3 for you. So the first problem is, now the sort of point of this section is to be able to, this first one is, translating from English phrase into mathematical language, basically, or mathematical equation, a formula. But really what's going on is, can you take something like this, right, an equation that has all variables in it, and isolate one specific variable? Pick out the variable you want to isolate. The rules for solving is exactly the same as solving equations that have coefficients, numbers, constants, and variables. It's just that it's a little different skill that you have to really remember that you're treating these variables just like you would a number. And that sometimes takes a little bit of practice. Well, the first one is just asking this translation. It says the surface area Q, surface area Q of a certain shape is equals 1/4. When they say 1/4, 1/4 the product of, now the product means multiplication of pi, and it's the product of pi. So it's pi, and then since it's a product, it's times, right? So multiplication, and then the square of its length. Okay, so it's 1/4 times pi. Probably make a better pi like that. Times pi, and the square of the length. So this is L squared, and that's it. So really, but really what we're doing more of in this, in the rest of these questions are, can you isolate, in this first case, let me use a little bit of green. It says, can you isolate for u? Essentially, can you think of u, treat u like the variable, isolate u. I think what I'm going to do is write this over here so I have a little space to work. This says g equals u times t. Once again, I'm going to put some green here. U is the variable I'd like to isolate. So I'm treating that like the x and everything else like a number. And so let me ask the question. If you have u times t, if you have these two things, these two quantities or variables, but they could have a quantity. If someone said t equals 5 and u equals 10, they could be a number. So if you have these two quantities and they're being multiplied, how do you undo them? How do you break them apart? What's the opposite or the inverse of multiplication? Well, that's going to be division. If I divide the right by t, I must also divide the left by t. T divided by t equals 1. And I end up with my desired u equals, let me rewrite that and make it look more like u. I'm left with u equals g over t. And that's the answer. Next problem, and for space, I think I'm going to take this and put it over here. This problem says y minus y sub 1 equals m times the quantity g minus g sub 1. This subnotation does not mean squared or have any kind of operator to it. It's just a way of distinguishing between g and g sub 1 or g sub 2. It's just another variable. So even though these are g's, they're different. They're still different. They're totally different variables. G is different than g sub 1, so they're not like terms. So be careful with that. And they're not powers. It's not g sub 2 would be like g squared. It's not a power. Let me make them look more like an L there. Okay, so now in this particular problem, how about if I use some red? They're saying solve for m. So we're trying to think of m as if m happened to be your variable and everything else needs to be put on the other side. We need to isolate. So what you can see here mathematically, when you have a variable next to a parenthesis, that is multiplication. So that red m and everything in this parenthesis is being multiplied. How do you undo multiplication? You do its opposite, divide, g minus g sub 1. If I divide that on the right, I must also divide that on the left. And actually, this problem solved pretty quick. M equals y minus y sub 1 over g minus g sub 1. So be careful. There is a sub button. Let me see if I can take a peek and see what it, so I can describe it. Oh, darn it, I don't see it. But anyways, there is a keypad that you could click on, and then an extended keypad. And one of them is going to have this kind of thing where you're talking about an exponent, and another one is going to have this sort of thing, which is a sub notation. So if you have y sub 1 and g sub 1, you have to use the sub notation button to get that little 1 to be down low. If you use the square button, it'll be something different, and it'll say you're wrong. Okay, let's take a look at the next one. In the next problem, we will go ahead and do right here. I'm going to write it as A equals Z minus V over R. And it's saying to isolate or solve, whoops, that's the shade button. Okay, how do I undo that? There we go. Or the highlight button, I guess. Solve for Z. So we want to get Z by itself. We're thinking about Z like the variable, and everything else sort of like a number that needs to go on the opposite side. So what I'm seeing here is, what are these variables being connected by? Well, this is connected with subtraction, and R, so we have Z minus V divided by R, so the division. Very first thing you're going to want to do is you're going to want to, and I guess I'll use a different color here, you're going to want to undo the division. The way you undo division is by multiplying by R. If I multiply the right side by R, I must also multiply the left side by R. And when I do that, R's will cancel, and that's exactly what I wanted to do. I'm trying to get every variable to the other side, leaving my red Z by itself. So now we've got R times A equals Z minus V. Once again, we're still trying to isolate our Z, our red Z, trying to get it by itself. And that red Z is connected, the operator subtraction. So if I want to undo that minus Z, minus V, I add V. And it zeroes out, leaving me with Z equals, be careful, we just added. Now this is an RA plus a V. Those are unlike terms, so you cannot put them together. You just write them next to each other. RA plus V. And maybe it might almost be better, maybe better to write that. Let's see if it maybe makes more sense or looks easier to understand. Because vertical addition with these kind of things gets a little bit confusing looking. We had what, RA on the left, and I'll use another color just to have something different. So now I want to undo this minus V. So how about if I add V, and so that just becomes a 0, and then I have to add V over here. Okay, maybe that's easier to see that way, and then that follows that we get that down there. So we're done. So we just finished, what problem is this? Number 4, RA plus V. There's your answer. Z equals RA plus V. Okay, something to mention, I think at least, and that is there is a convention or a guideline now that when you have two variables being multiplied, you may want to put them in alphabetical order. I don't really have a problem if it's not, because R times A is exactly the same thing as A times R. It's not going to give us a different mathematical outcome, but if you have a really complicated problem, a lot of times you're going to try to get your variables like X, Y, Z, try to get them in alphabetical order so they're easier to identify when they look the same, right? So that is a convention that some books hold really, really close to. I think most math instructors would know that, you know, both of these would be fine because they mean the same thing. This program, I'm noticing I just went through and put all the answers in just in multiple ways to see if it became a problem, and it didn't. So it accepts it that way. That was just a little side note. Okay, next problem, number 5. Now this gets a little tougher. Let's take number 5 and let's rewrite it up here for space. This is number 5. Number 5 says H equals K times M sub 1 times M sub 2 divided by S squared. Okay, I believe, what are we solving for? Let's isolate what we're solving for. It says we're solving for M sub 1. So M sub 1 could be thought of like the variable we want to get by itself. Another thing that you can do, which I think, I don't know, could maybe be a little bit helpful, is think about this K as K over 1, right? It's just being multiplied. That just means, that just is telling us that K is up top with everything else. So what I'm going to, so it's just K, M sub 1, M sub 2, they're all being multiplied. Order doesn't matter. I'm just going to go ahead and write M sub 1 in the front because I know I got to get that by itself. And I'm going to write K times M sub 2. But once again, multiplication is commutative, which means the order that you multiply doesn't change the outcome. So changing the order in multiplication is never a problem. This is all over S squared. Now let's see, what can we do? Well, I want to isolate the M sub 1, green, M sub 1. And I have this whole product divided by S sub 2. I need to get that out of there. I need to get that S sub 2 out of there. So I'm going to multiply this by S sub 2. And you can think of it as over 1 you want, but it's just an S sub 2. I'm sorry, it's not an S sub 2. It's an S squared. Wow. That was a bad misquote there. Or I misspoke. So this is H. And then if I multiply the right by S squared, I must multiply the left by S squared. Now, go ahead and see what happens. Those S squares will reduce. I have H times S squared equals M sub 1 times K times M sub 2. And I'm going to go ahead and make that green again just to kind of highlight that I'm trying to get that by itself. So something that you should be remembering is that this is all put together or bonded by an operation called multiplication. How could we undo that? Its inverse multiplication is division. So if I simply divide by K times M sub 2 on both sides, these will reduce down to 1, leaving me with my M sub 1. And on the left, I've got H times S squared divided by K times M sub 2. And like I said, I tried putting that in different order because multiplication you can, and it didn't seem to make a difference. So that should be fine. What I mean didn't make a difference. It wouldn't make a difference to me because I believe in the commutative property. But I was just checking the computer's ability to recognize that. So number 5 is going to be H. Let's put on top H times S squared, and this is all divided by K times M not squared sub 2. All right, let's move on to our next problem. Now the next one, this one's not, it could be worse, but it has a trick that the other ones don't have in it. So that's what makes this one really tough, because it has something that you have to see that we haven't had to do so far. Now, I guess what I'm trying to show, let's go ahead and just write this right here. This is going to be X plus H times ZF. And you can see, what are we trying to isolate? We're trying to isolate the H. The problem is we've got terms with H's in multiple places. So if you try to isolate it, you're going to have an H on one side and an H on the other side, That's not isolating. They're separated. So you have to remember something that, wait, there's an equal sign somewhere, I think. I'm missing something. Let me erase that. That should be an equal sign. How many people were just like itching going, what's going, okay, well anyways, yeah, I caught it. So it's x equals h plus hzf. So the problem here is you have to realize there's something called factoring. And factoring out a common factor, and I got it nicely highlighted in red, h is the common factor between those two terms. So you can actually factor out that h. And you know you factored it correctly if you distribute and you get the same answer. So what does this factor out? It's sort of like dividing h on each term. What's h divided by h? 1. What if I divided h out here? Well, then I'm left with zf. How do you know that you factored it correctly? You can use the distributive property to check it. H times 1 is h. And h times zf is hzf. So we factored it correctly. Now, why did we want to do that? Because we have two h's in two locations, and now we have one h in one location. Now, h in this parenthesis, this factor, is put together with the operation called multiplication. And we know that we could undo multiplication with division. So we can't just divide by one little piece. It's got to be the whole parenthesis, a carbon copy of it, which is 1 plus zf. This whole factor is the same, so it reduces down to 1. And of course, we must do both sides by that same quantity, 1 plus zf. So let's see, let me see if I can kind of clean this up. The answer is, I'll just keep the h on the right just so it looks the same. You have an h right here, and that equals x over 1 plus zf. And of course, you could always put the h on the left and this x over 1 plus zf on the right. Doesn't matter. In fact, here we see it right here. The answer is x on top over 1 plus zf. That's number 6. Okay, let's move on. And 7 and 8. So 7, I think 8's going to have to, I think we'll take 8 and bump it down here for space. Okay, so 7 will go, my pencil's not working, there it goes. 7 will go right here. So 7, it says A equals 7 thirds times h minus 98. And it says to solve for h. Solve for h. So h is definitely hard to get to, right? It's sort of nested inside this thing. And there's multiple ways of doing this. You could multiply both sides by the reciprocal, which would be 3/7, which would reduce that, and then you'd be on your way. And that's not a problem. I think that's a great way. Sometimes some students get a little bit messed up by that. A lot of students will say, well, I'm going to distribute. Well, you can do that too. Multiplying by the reciprocal probably is a little bit quicker. You could also divide it by 7 thirds, and then you'd have to flip it. But anyways, there's multiple ways to tackle this problem is what I'm trying to say. So I think a lot of people would say, I want to distribute. So I'm just going to go with probably a common way. Distribute would be 7 thirds h, and you distribute. And if you distribute this, you're going to multiply. Let's see, what are you going to do? You're going to multiply. Let me just grab a calculator real fast. So I want you to think about this 98. You could think of it as a fraction, right? So when you multiply fractions, you multiply the numerators. So what I'm going to do, and maybe I'll take a little note over here. a little note. I'm going to multiply 7 thirds. Actually, I'm going to take more space here because I'm going to run out. I'm going to multiply 7 thirds times 98 over 1. That's going to give me 7 times 98, which is 686. And then 3 times 3 in the denominator is, 3 times 1 is 3. So if I divide that by 3, I end up getting a fraction or a mixed number. And when I look back, the way they want us to input it, it says, simplify your answers, type integers or fractions. Okay, so we don't want decimals. Okay, so this is just going to be A equals 686 over 3. All right, let's go like this. Let me, oops, that was getting rid of a little too much. So, so now here we are. What are we supposed to be isolating? We're supposed to be isolating this green H right there. Okay, before we try to isolate that, I think, well, it's not just I think, we really need to get the H terms by themselves. And you got this piece here. Let me use another color. So I'm going to use the orange color. If I have a negative 686 over 3, I can turn it into 0 by adding that positive value, or its opposite. So now I'm going to add that to both sides. Okay, and of course this zeroes out. And now I'm left with A plus 686 or 686 thirds. That equals 7 thirds times H. You can, so now we want to isolate, still want to isolate this green H. You can divide by 7 thirds, but then you'd have to flip and multiply on the other side, a little bit messier. So really the preferred way, the further we go up, is I can turn any fraction into 1 as long as I just multiply it by its reciprocal. So I'm going to multiply 7 thirds by its reciprocal, because I know when I multiply something by its reciprocal, it just turns that into a 1, right? 3 times 7 is 21. 7 times 3 is 21. 21 divided by 21 is 1. So a lot of nice things happen real quick, and that's why we did that. Oops, if I do it on the right, I better do it on the left. The left has 2 terms, so I'm going to distribute 3/7 times A, distribute 3/7 times 686 over 3. All right, I'm running out of space, but I think it should, hopefully I could write on the next page. Now we've got 3/7 A, and when I multiply the numerator and then the denominator and then divide it, let's see if I actually get a nice number. You can follow along with me on the calculator. I'm going to multiply 3 times 686, enter. I'm going to divide that by 7 times 3. And by the way, because this is multiplication, you could have reduced the 3's before you started, but I didn't. So I'm going to divide by 21, and I'm getting 98. So we have 3/7 A plus 98. And over here, this nicely reduces down to just 1. And so you got 1H. There's my answer. And that matches up the way they'd like us. See, they were very specific on how they wanted us to do this, because, you could have, maybe you would have left it without distributing it. There's different ways to write this answer. So that's why they forced you to write an A here. Whoops, it's erasing. They forced you to write an A there and a plus there. Okay, let me get rid of that. So they forced our hand, so no problem. We got it. It is 3/7 A and then plus 98. Plus 98. All right, so that's good. Excellent. That's number 7. We need to get number 8, and I'm going to put number 8 down here because of space. And I got a lot of space down here, so I think I'm good. So I'm going to take 8, and 8 says 3x plus y equals 6. It says we'd like you to please solve for y. And so this is going to be not too bad, right? How do we get y by itself? Well, we have a plus or a positive 3x. So if I just subtract 3x from both sides, that zeroes out, right? And I get y equals 6 minus 3x. And that would be a fine answer. We find out later in this chapter, coming up real soon actually, that there's something called slope-intercept form. And slope-intercept form is y equals mx plus b. And so we always put our x term first and our constant second. So, you know, when I see this, I almost can't help but put it into that form. But they both mathematically mean the same thing. And at this step, you know, you can put it in either way. Okay, so that would be y equals negative 3x plus 6. Or the other way, 6 minus 3x. Number 9. Number 9 is 7x plus 3y equals 23. Once again, this one is saying to please solve for y, so we need to isolate the y. You can see that this says plus 7 on the left, so what we need to do is we need to get that out of there. We need to zero it out. Whoops, didn't mean to write a 0 when I said 0. We need to zero it out. And so, of course, so opposites make a 0. If I subtract 7x on the left, must also do that on the right, but keep that equation balanced. Now I've got 3y equals, like I said, I like the x first because it's slope-intercept form, so I'm just going to rearrange the order, and that's no problem as long as you take that sign with it. Last step, I want 1y, so I just divide by 3 on each term. And I get my answer, y equals negative 7/3 x plus 23 over 3. Okay, right. And of course that could be written as a mixed number. Mixed number, writing something as a mixed number does not reduce it. It just writes it in a different form. Usually, further you go in math, we like improper fractions because you could take the reciprocals, things like that. But when you're graphing, you know, if you're graphing or doing anything like that, or looking on a ruler, excuse me, looking on a scale, improper fractions are kind of a pain. And so writing them in a mixed is nice when you're graphing. Okay, last problem, I believe. Yes, number 10. Number 10 says 1/4 x plus 1/8 y equals 4. And you know what? I'm starting again. I'm gonna get it. I'm gonna actually do this problem twice, showing you a couple different ways to do this. If you want, you can fast forward if you don't. 1/4 x plus 1/8 y equals 4. Okay, so one way is to think of it just like we've been doing the whole time. I want to isolate y, so I want to get all terms with y's on them by themselves. So since this is a positive 1/4 x, I better subtract out a 4th x. I'm going to do that on both sides. So that zeroes out there, leaving us with 1/8 y equals, and as you know, I like to put the x value first, so I'm putting it in slope-intercept form. That's just something drilled in me, and so you go either way at this stage. If they say slope-intercept form, you would have to do this. Okay, last step, we need to make this a 1y. One way is to divide by 1/8 and then divide each term by 1/8. That's a little messy, isn't it? If you believe that a reciprocal turns a number into 1, and I hope you do, then it's probably a little less messy to think of this as 8 or 8/1. I did that to the left term. I must also multiply this by 8 or 8/1. I must also multiply this by 8. By doing this, I'm going to have to simplify or reduce 8 over 8, simplifies down to y. That's looking good. This is a negative times a positive, so that's going to be negative. And this is 8 divided by 4, which is negative 2x. And then we've got 4 times 8 is 32. So that's done. So another way to do that problem is, let's see, let me write it again. So we've got 1/4 x plus 1/8 y equals 4. Isn't that the original problem? I believe so. Once again, trying to isolate the y. So I'll go ahead and highlight that for us. So remember, often when we have equations, often the recommendation is to clear fractions, because then we have a new equation that gives us the same answer, represents the same line and all that stuff, but it doesn't have fractions, unless you're solving for something and they pop back up again. But let's go ahead and multiply both sides of the equation by the LCD. The least common denominator for a 4 and an 8 is 8. So if I multiply every term on the left by 8 and every term on the right by 8, I clear the fractions of this equation. 8 divided by 4 times x is just 8 divided by 4 is 2x. And these 8s are reducing nicely, or simplifying down to 1. So now I've got 1y. 4 times 8 is 32. And so this problem actually is much easier if you do it this way. Subtract 2x on both sides. And of course, zeros out there, we get y equals negative 2x plus 32. So this is probably the preferred way, but in math, you can take the short way, the longer way, the middle way, the longest possible way. We try to go the short way, but if this way made sense too, that'd be fine. The main thing is if you're following the rules of math, the format, or the rules of the addition, multiplicative properties of equality. Do something on one side, you must do it on the other side, and things like that, and you can really take your own path. All right, I hope this helped. I'm going to post more homework video solutions just to get people rolling if they have questions after they already looked at the videos and tried. And this is Professor Gonzalez signing off, and you take care. Bye.